Hello, my name is Keshwani. That's Keshwani, Keshwani. I have been solving math problems for GRE out of this book here, practicing to take the GRE general test, the 10th edition. If you do not own this book already, purchase one immediately. The problem that I'm about to solve is the one that you're going to find on page number 328, quantitative comparison question, number 13. Let's take a look at this problem. But before I actually solve this particular problem, let's have some fun. I'm going to give you a problem. And then of course, this being a video, you can pause it as many times as you wish. So I want you to pause the bloody thing. I want you to solve the problem that I'm about to give you. And once you have the answer, then you can resume it and compare the work as to what's going on. Here's the problem. So the problem that I'm about to give you is not the one that they give you in the exam. It's just something for extra fun. See, when we're having fun, why stop it a little bit? So let's have some extra fun. So here's the problem. Here's your triangle. A, B, C. This is 10. This distance from here to here is 6. And the question simply is, they want you to compare area of triangle ABC versus 30. Now before we go any further, I don't want anybody to sit there and freak out about the fact that this other short distance is labeled as 10 units, whereas this distance from B to C is labeled as 6 units, even though it looks much longer than this one. It does not matter because pictures in this exam are not drawn to scale. You must understand that by now. This is not your good old days, the exam that you took many moons ago after high school, the SAT. In the SAT, all the pictures that they give you are all drawn to scale. So in the SAT, if one line looks shorter than the other line, you can safely assume that this line is shorter than the other line. This is not the case here. These pictures are not drawn to scale. So I'm telling you that this distance from A to B is 10. All I want you to do is pause the thing now, figure out the area of ABC, triangle ABC, and compare it versus 30. Okay? I'm going to get out of the frame for 5 seconds so that you have a clear view of it. Pause the thing as I said, solve it, and we'll come back. Alright, so that was that. What did you find for the answer? If you're sitting there saying to yourself that there is no way we can figure out the height of this triangle, well, that actually there are two kinds of people who are going to pick the wrong answer. One category of people who's going to get the wrong answer are the people who are sitting there and saying the area of the triangle ABC is 1/2 base time. I'm not sure how good this color is. I don't know how easy it is for you to be able to read it. I stay with black because black is easier to read. It's more legible. 1/2 base times height. Most people who sit for this particular exam know this thing, that the area of the triangle is 1/2 base times height. So they sit there and they say 1/2 base, which is 10, we know that, and then the height, they look at it as 6, and they can arrive at here. So this 2 cancels out with this 10, we get 5, and 6 times 5 is 30, and they arrive at the answer of C. I shouldn't put a star next to C because when I put a star next to an answer, it has certain significance. So they arrive at the answer of C. This is the first category of the people who would arrive at the wrong answer. Answer is not C. Answer is not C because the height of this thing is not 6. What does it mean for height of a triangle? What does the height of a triangle tell you? Height of a triangle tells you exactly what it says. The height of the triangle is so called because it tells you how high the bloody thing is. How high the bloody thing is from the base. For example, let me do one more here. If I tell you, how high is this picture? How high is this triangle? If I tell you that from here to here is 100, that does not mean that this triangle is 100 units high. The height of this particular triangle is to be determined like this. You draw from the base, you draw, extend it out, and this distance right here is the height. The distance from here to here is not the height. Similarly, distance from B to C is not the height. That is incorrect. 6 is not the height. So what is the height of this triangle? The second category of people who get the wrong answer here are the people who are a little bit above this level, because this level people the first category of people, they actually assume that the height is 6. The second category of people, the higher level, little bit higher level people, are those who realize that the height of this thing is not 6. The height of this triangle is actually this. Oh boy. I think I should just throw this thing away, because you cannot read this at all. I don't know why I would buy this bloody thing. It's yellow and it cannot be read. What I need is a red marker, which I ran out of. Because, anyway. So let's see if we can find another color. Oh, how about green? This distance from here to here, let's call it C to D. This distance from C to D, this distance is the height. And there is no way you can figure out the height of this triangle. There is not enough information in it. And that's the second category of people who would realize that the height of this triangle is not 6. The height of the triangle is exactly what it says. The height of the triangle tells you how high the thing is from the base. The base is this, so you extend the base out, and this distance C to D is the height. And since we do not know the height, the second category of people who are taking the exam will sit there and say, the answer is not C, the answer is D, because we cannot figure out the height. Well, they are right. We cannot figure out the height. They are correct in saying that we cannot figure out the height. Their problem is that they still have not quite understood, despite my repeating over and over again, that these questions are called quantitative comparison. They are not called quantitative computation. Nobody is asking you to compute the area of the triangle ABC. Nobody is asking you that. That is not the point here. The question here is not what is the area of the triangle. The question here is, how does the area of this particular triangle compare to 30? Is the area of this particular triangle equal to 30? Is the area of this particular triangle less than 30? Is the area of this triangle ABC more than 30? That's what we're looking for. We are supposed to compare the bloody thing, not compute it. And if you understood that last part, then you will you will graduate yourself to the third category of people who eventually do get the question right. Here we do not know the height of this triangle, what it is, but whatever the hell it is, we do know for a fact that it's got to be less than 6. It's got to be less than 6. This is how we write less than 6. 6 with a minus sign on top. That tells me that whatever it is less than 6. Now how do I know? How do I know that this distance C to D is less than 6? Because this distance at an angle, at a slanted angle, this slanted angle here, a slanted line rather, is 6. So if I tell you that this line is 6, then the one that is coming down straight has to be less than 6, obviously. If the ladder is 6 feet tall and is touching the wall, if this ladder from here to here is 6 feet tall, 6 feet long rather, and it's touching the height, then the height that it's going to reach, the highest height it's going to reach, it's never going to be equal to 6 feet, because the only way this ladder is going to be, this height is going to be 6 feet is when this ladder is actually parallel to the wall. It is, as you can see quite, it's an angle. So this height from bottom of the floor to the top of the ladder, it's got to be less than 6 feet, because the entire length of the ladder is 6 feet. That's what it is. The height of this triangle, whatever it is, it's got to be less than 6 feet. And that's what we have to use here. This is less than 6 feet. Therefore, 5 times something less than 6 feet has to be something less than 30 feet. and we are asked to compare this against, we are asked to compare it against 30 feet, and therefore the answer is B. Voila, this is the correct answer. That is the correct answer. Do you understand? There you go. Now what I'm going to do is run down to the back of the camera and see how much time I have taken up, because I didn't mean to take up this much time in this particular question, because we haven't quite done the problem yet. So give me a second. Oh boy, oh boy, oh boy. We are more than 10 minutes into it. But that's okay, I'm not quite done yet here before I actually solve the problem. I want to do a little bit more, okay? So I'm going to erase all of this thing. I hope you understood this thing, that this was not the right answer. This is not the right answer. The correct answer is B. The correct answer is B. One more time, because the height of this triangle is less than 6 feet, or whatever unit may be, 6 inches, 6 yards, whatever it is, less than 6. This side is less than 6 because I know that this is 6. And therefore, if this is less than 6, then one half base, which is 10 from here to here, this is the base, 1/2 base, times height, which is less than 6, 5 times something less than 6 is got to be something less than 30. Something less than 30 versus 30, therefore the answer is B. Voila. Let's do one more problem, a different one. I'm going to erase all of this thing. So I'll give you a second here, 5 seconds here to freeze it if you like it, and see, look at it before I actually take it all away. Alright, here we go. Let's do one more. Let's do one more problem. Let me use the black pen. So, from here to here is 12. This distance right here is 12. And then from here to here, let's call it P to Q, is 10. Let's call this A, B, C. What I want you to do is compare the area of, triangle compare the areas rather, not area, areas of triangle PQA, triangle PQB, and the triangle PQC. Again, I'm going to get out of the frame. I'm going to let you pause look at it for 5 seconds. Pause it. I want you to pause this thing. I want you to look at it. And once you have the answer as to how does it compare, which one is the, out of the 3 triangles here, which triangle has the highest area, which triangle has the lowest area, and so on and so forth, which one is the middle one. Once you have the answer, we'll continue the work, okay? Okay, so what did we find? The area of the triangle, this is how we find the area of a triangle. 1/2 base times height. And as I explained a little while ago in the previous example, the height of a triangle is exactly what it says. The height of a triangle tells you how high a triangle is. And in this case, all of our three triangles, triangle PQA, triangle PQB, and the triangle PQC, they all have the same height. They end, all of them end here. This is the height of 12. They all have the same height. You didn't need to know the 12 part. That was 12 part is superfluous. It doesn't tell you. It actually tells you what the exact area of the triangle is. But we don't need to know that information here because we're comparing the area. We're not computing them. The areas of these three triangles, triangle PQA, is equal to the area of the triangle PQB, which is also equal to which is also equal to the area of the triangle PQC. They are all equal. Why? Because they all have the same base. The base is this. This is the base. They share the base, and they all have the same base of 10, and they all have the same height. From height is here to here, which is 12. They all have the same base and the same height, and it's 1/2 base times height. Therefore, the area of all of these three triangles is whatever it is. 1/2 times this amount. So this 2 is going to cancel out with this 10. So it's just 60. The area of all of this triangle is 60. That's all. I'm going to draw few more. How many are there? There are infinite. It could be anywhere. I could go from here. I could go from here to here and here. It will still have an area of 60 as long as the height is, the last triangle that I drew also has the height of 12 and also has the base of 10. So this last triangle that I drew, triangle PQD, also has the same height, same area. All of these four triangles have the same area. Do you understand? Now let's do the actual problem that they give you. Now we'll do the actual problem that is given to us in the exam. Alright? Perhaps, as always, I'm making too much fuss about nothing at all, because half the people did get this question right. 50% of people who took this exam got this question right. Only the other half had the problem. So now let's look at the problem here. It says point S not shown. No, they're not showing it to us. They tell you that it lies above the x-axis such that the triangle RST has the area of 6. So let's just draw this thing here that they give us. Where's your 0? 1, 2, 3, 4, 5. There you go. Here's your R. Here's your T. R, S, and T. They don't tell you where the S is. So somewhere up here is the S. Somewhere up here is the S. And they tell you that the area of triangle RST equals 6. Well, how do you find the area of a triangle? The area of the triangle is 1/2 base times height. And we know that has to equal 6. The base of this particular triangle is very simple. The base is from here to here, from 1 to 5, which is 4. This is your base. That's the base of the triangle from here to here. It's just 4 units. So base is very straightforward. 1/2 base, which is 4, times the height has to equal 6. This 2 cancels out this 4. So 2 times h equals 6. That tells us that the height of this particular triangle is 3. Let's put it up here someplace. Let's call it 3. Now the problem here is that we do not know where S is. So perhaps we do not know where S is located. I'm going to give you two easy scenarios first. Scenarios that are very easy to see. You see, RST could be like this. Let me change the color. The triangle that we have in mind could very well be a right angle triangle, which is very easy to deal with, but it could be a right angle triangle like this. RST. In which case they want you to compare. In which case they want us to compare. Let's erase all of this thing because I need the room. So height of this particular triangle is 3 is what we have to figure out. And you will see why we have to figure out the height, because they want us to compare the y coordinate of S versus the x coordinate of S. Versus the y coordinate of S. But here's your S here. In this particular case, it's very straightforward because we are at 1. So x coordinate is 1. And the y coordinate will always remain 3. It doesn't matter where the S ends up, the y coordinate will always remain 3. Because we just found out a little while ago that this height of this particular triangle has to be 3 because of the fact that we are told that the area of the triangle is 6. If the area of the triangle is 6, it is 1/2 base, which is 1 to 5, which is 4. This distance here is 4. 1/2 times 4 times height has to equal 6. One more time I'm doing it. So 2 times h equals 6. It tells me that s is 3. The height is fixed. Height of this particular scenario is fixed. The y coordinate of s, regardless of where s ends up, has to be 3. This is 3. This is fixed, it's determinant. The problem here is that we do not know the x coordinate of s. The s could very well end up here, or we may have a situations that looks, it's still a right angle triangle, but looks something like this. Instead of the leg being here, it may be over here. In which case, let's call it S1 for the first scenario, and let's call this the S2 for the second scenario. In this case, again, the y coordinate is fixed. It's not going to change. But now the x coordinate is 5. Before in scenario 1, with S1, the x coordinate of S was 1, and y coordinate of S is fixed. It's always fixed as 3. 1 versus 3, the answer was B. Now, the x coordinate of S, the second scenario, which is what we're calling here S2, with S2 now, the x coordinate of S is 5 versus 3. Again, I put a box around 3 because it's fixed. It's not going to change. Now the answer is A. Before the answer was B. Since the answer switch, we cannot tell. We do not know where S is located. S could be here, X could be here, or S could be anywhere in between here and here. So the answer here is that x coordinate of S can be anywhere between 1 and 5. We have no way of knowing where it is. And in all of those cases, the area of the triangle will remain 6. So I'm going to draw a few more triangles that we're not going to actually talk about, but I'm going to show you there are infinite possibilities. So I'm going to show you here. But here we are done, that's it, because the answer switched from A to B. The correct answer is D, because we cannot tell. That's it, the correct answer is D. So what I'm going to do is I'm going to reproduce that down here, because I don't want to ruin this thing, and I'm going to show you a few more scenarios. So here we go. So the scenario that we're dealing with here is that the height is 3, we're starting out with 1, and we're ending at 5. So we may have a triangle that looks like this, or we may have a triangle that looks like this, or we may have a triangle that looks like this, or like that, or like that. There are infinite possibilities. There are infinite possibilities between 1 and 5. You understand? So we do not know where S is. S answer could also be C. S could actually be exactly maybe at 3. It could be anywhere. Do you understand? So the answer could be A or B or C, because the answer keeps switching. The correct answer therefore is D, because we cannot tell the x coordinate of point S. That's all. That's it, we are done. I hope you found it helpful. If you wish to get hold of me for personal private tutoring, I do face-to-face tutoring. I also tutor over the internet via Skype, and I also do consulting over the telephone if you need help over the telephone. So some people find it helpful. If you wish to give it a shot. If there is anything at all that I can help you with in your preparation for GRE, go to my website at www.for4gre.com and send me an email. Or you can go to www.KeshwaniPrep.com and send me an email. Alright? Thank you.